I'm late, but let's get started. As usual, waiting for Twitch to catch up. And I should be live. Hello everyone. Welcome back to the Advent of Code. Usually there's like a year-long gap between streams because I used to only stream for the Advent of Code. Now the compiler project, last stream was just on Sunday. But yeah, let's start with the Advent of Code. I'm gonna do days 1, 2, 3 this evening. Hopefully everything goes well. And if it is early, I will then switch back to the compiler project to try to make some progress. The thing I don't know is since this year there are only 12 days of the Advent of Code instead of the usual 25, I expect the difficulty to ramp up a lot faster than it usually does. So we'll see if I can go through all 3 first days this evening. Hello, how are you? So yeah, let's get started. So I had a quick look at the puzzles, but I haven't yet looked at what part 2 will be, because again, since I do those live on stream and part 2 isn't unlocked until you do part 1, I don't know yet what part 2 will entail. So there's gonna be a fun live surprise. So day 1 didn't look too difficult. We have a series of, I'm actually gonna copy this, left or right things, and we need to keep track of the value that is being pointed at by the current value. We start at 50, and it's a modulo 100, if I remember correctly. Dial starts by pointing at 50, and above 99 is 0. So yeah, modulo 100. But we are not counting the number of times where, like the final position, we're counting the number of times it points at 0. So let's get started. I have my template here already, so I can use that. And here I'm just gonna do, actually I'm gonna remove this and do a very simple replace. And there we go, to have the test data that we can compare our code against. Do I want to go extremely overkill immediately and still use parsec for parsing the input? And I kind of want to, because it's kind of funny to do. So our input is going to be a list of instruction. What is an instruction? It's a direction and an int. What is a direction? It's left or right. So let's be extremely overkill about this, even though we could probably do this in an easier line. So we're gonna use, I have my library of functions I've been carrying around for 10 years at this point, or a bit less because I didn't start with the Advent of Code, but close to that. So I have, for instance, parsing there. I have parse lines with, which takes the string of the input, cuts it into line, runs a given parser on each line, and I have a few very basic parsers already there, so I can already make use of that. How do we parse a line? Parsing a line is going to be parsing a direction, and then a value, which is going to be parsing a number, and we will return a tuple of direction and value. And parsing a direction will be a choice of, so I think I have choice in my aliases. I have try all, I think. Try all, which is, it's just a map of try on choice. I can just use choice in this case because there's not gonna be a need of backtracking because the first character will be enough. And so that choice, which do I really need to make the choice? I could just write it the operator, is gonna be left or right. And we're gonna pass through with the I think it's been too long since I've used parsec. I think it's just the character thing that I want. Yeah, that's what I want. So either we get L or we get R. So that should give us something that works. We can already try by printing the test input and checking that this thing is being parsed correctly when this compiles, which it won't at first, but you know. Ambiguous. Oh, because I already have something, I'm just gonna hide it. I think my direction type in my library is my cardinal directions, north, south, west, east. Ambiguous occurrence left, prelude left. Yes, I suppose. So if I have conflicts everywhere with this thing, no, I think I want to keep those name, even though they conflict. They conflict with the either thing. Okay, this compiles. This prints left 68, left 30, right 48. That looks pretty good. Left 5, right 60, and so on. Perfect. So now what do we do in part 1? We take this input, we return an int, and that int is the number of times that the cursor was on 0. So this is going to be a very basic fold over the list of things. Our function is going to be a step function we're going to define, and our accumulator is going to be, we need to keep track of two things. Where are we currently? How many times did we end up on 0? So we start at 50, and we have been at 0 times so far, and we are doing this fold over the inputs, so that's about it for part 1. So what do we do at a given step? At a given step, we have the position and we have the occurrences, and we have an instruction, which is a direction and an amount. What we do there is just depends on the direction. I realize I could have just switched back to the big screen, but it doesn't make a big difference. Well, I don't even need to do that, really. The new position is going to be the position plus... I guess I can do that. Okay, so it's position plus k's direction of... How do I want to do this? Do I want to integrate the k's within? Maybe not. Like, so the difference is going to be based on the direction. If we are going left, it's going to be minus the amount. If we are going to be right, it's going to be the amount. The new position is going to be... Oops. There we go. Position is going to be the position plus difference mod 100. I just want to check quickly, GHCI, between mod and reminder, which one handles negative values correctly. If I do -1 mod 100, I get 99, but if I do reminder, I get -1, so it's mod that I want. I never remember which is which. And so our the step function calculates the new position by applying the instruction, which I guess I could have made a separate function for this, but it's fine as is. We might do a separate function if we need it for part 2. And the new accumulator after a step through our fold of instructions is going to be the new position. And occurrences will be the old one, plus 1 if the new position is equal to 0. So that would be from enum of new position equals 0. I'm using from enum because Boolean is an enum. So from enum of true will give me 1. From enum of false will give me 0. So if new position equals 0, that's true, we do a +1. That should give me part 1. Let's try this. For the test input, we are expecting to find the 3 as being the number of times. Yeah, so hopefully when this compiles, expected int instruction int actual. Oh, because here this function returns an int, and this fold will return the value of the accumulator at the end, which is 2 different values. We don't care about the first one, which is the current position. We only care about the second one. Okay, we do get 3 for our test input, so it means we are correct on the test input. Perfect. Let's try to see if this part 1 thing is correct, or if I've messed up something. That's the right answer. Perfect. So what is part 2 about? Okay, so this is very similar. We're just counting the number of times we have passed 0. And yeah, I was thinking the same while doing it, of like, I could convert the instruction into just being plus and minus a given number. I wasn't sure what part 2 was about. So if part 2 made like left and right do very completely different things, I didn't want to have an int in my input that would just like encode what this thing means for part 1. Granted, for this particular day, I could have made this assumption, but in general, I tend to keep the input very close to what is described because I don't know what part 2 will require, and maybe I would be making assumptions about what the shape of the input is that would turn out to be wrong in part 2. But yeah, here in this case, I could absolutely have converted the input to a list of int. That would have been perfectly fine. Okay, so here the obvious bad, it would work answer is to just do a brute force of to just do a loop that iterates the thing and counting whether we end up at something that is 0 or not. That is like in the middle of the iteration, but there is easier. There is, I think, well, better. So let's do part 2, which is going to be extremely similar. The difference, so basically this code is the same, which means I'm gonna extrapolate, I'm gonna move into a new function, which is gonna be apply, given an int and an instruction, or rather an instruction and an int give me a new int, and apply will be apply is just going to be a case of, I can't do that sadly, so it has to be direction amount, and it's going to be a case of the direction of left, and we return the function subtract amount, or right plus amount, subtract. There we go. So the difference here is just no longer any need to do that. This is purely apply the instruction to the position. And I don't want to do the modulo 100 in that function. So we keep everything here. Now, the only thing is, I will want to check not just that the end position at the end of this is a 0. I think what I want to check is... I mean, using brute force is a valid approach for something like this, right? It's a very logic way to think about it, and it will get you the result. In a lot of actual real world situations, brute force is not necessarily the worst if you can guarantee that it fits within your time constraints. It's definitely a lot less dev time, but it is less fun than trying to find a proper solution for this. And I think here, very naively, I suspect the easiest way to do this is, did we cross the boundary at the end? I think that's the basic thing, and that would be basically, here we don't do the modulo 100 on the thing, and we do instead, we do it here, and what we do here instead is we have this thing, which is going to be the new position is less than 1, or the new position is greater than 99, which means we have crossed over regardless of where we end up. Because I think that would work, right? There's no way to have to cross a 0 without either ending at 0 or below 0 above 100. Above 99, I suppose. And that should be therefore from enum crossed 0 here. Are we using the same test input? I think we do. For the same rotations, okay. The dial points at 0 a few extra times, and we should expect a 6 if this compiles and runs. Multiple declarations of part 1. Yes, it's supposed to be part 2 here. Okay. Oh, yes, of course. This is position occurrences. And this is instructions. Oh, hello everyone. I just need to fix this here as well. Instruction singular. Okay, now if this compiles, we should expect a value of 6 for the test input on part 2. We get 8. So we got something wrong. Hello, how are you? Aha, I know what I got wrong. That is, of course, the edge case of we started at 0, and if we start at 0 and then we move negative, we will, of course, count this twice. Well, we should only be counting it once. Yeah, I've just started this evening. I've barely started. So this approach doesn't work. And I guess it works. I guess it works if we did not start at 0. Because if we started at 0, we counted it at the end of the previous iteration, and this one, regardless of what we do, unless we end at 0, could there be a plus 100? Is that something that's possible? There isn't. Oh, but there are rotations by large numbers. That's something I didn't take into account either. We could be crossing the 0 more than once in a given rotation. Yep. Yep, indeed. Okay. So how do I do that then? Because I would like to not do the brute force approach. This doesn't work. We can get rid of it. Okay, so I need to be careful with ending on 0 already. Like basically, I need to not count the starting 0. That's what I need to be careful about. I need to count all of the other zeros. Hmm. Let me think for a second. I suppose I could do a basic division and get, for instance, we rotate and we go all the way to, I don't know, 200 or something, 205, and I divide this by 100, and I know I've crossed the barrier twice. So I guess I could do a diff and look at how many. Nah, that doesn't work. Because again, I don't want to do the brute force. That's too easy. That's not interesting. So let's think. I guess I could do that with a div mod. I guess I could use the same approach with a div mod. The div gives me the actual base number of things. Yeah, okay, I think we can do something like that. So, that means so I'm going to rewrite this, I suppose, then. I'm not going to use this function because I will want to know the actual diff. I will need to know the amount. Oh, I guess I could. That being said, no, I could probably just do. Okay, so let's do this. I'm going to have my instruction, which is a direction I don't care about and an amount. One thing I will need will be, okay, that amount, if I divide by 100, and I will have to check there again the quote versus divide thing. If we rotate by 500 and I divide that by 100, I will get -5. If I do a quotient, I will get -5 as well. Okay. So I will need the absolute amount I'm gonna name it X until I figure out a better name. That's gonna be the basic number of, okay, we've been doing 5 rotations, we've crossed 0 5 times, no matter what. Then we're gonna have how much did we actually move from our starting position, which will be, and I need here this to be the absolute amount. I have a mod here is fine. The mod gives me the actual difference. New position will be a case of the direction. Okay, so just let's rewrite this. And let's not use our previous function. Let's use the direction. If it's left, then it is our starting position minus the minus y. Otherwise, it is position plus y. And I think here we can do that thing of like the additional 0 will be if the new position is less than 1 or it is greater than 99. So we have crossed one last time after looking at the modulo. And the position wasn't 0 in the first place, because if it is, then we didn't cross anything. Okay, X and Y are absolutely horrible name, but I think that the logic otherwise is sound. And we will return then the new position after having moved. and this will be the number of occurrences plus what is badly named x and what is better named the additional 0, which will be likewise a from enum. I'm not sure this is going to work on the first try, but at least we can check. We get 7, so we still get something wrong. Oops, I didn't mean to do that. That's a little bit annoying. Let me just quickly redo that. So we still got something wrong here. I suppose we should check what we get if I do instead. I could make this function return a list of int and int, and return a scanl instead, and return the full list of the accumulators as we go. It's not in scope. I'm gonna need to import it. Wait, am I misremembering the name of the function? It's just that there's no scanl prime. There might not be a scanl. Oh, there's one. So I do need to import it. Okay. So let's try to see what's wrong, and let's compare with what we get. Okay. So we start 50 at 0. And after one step, we are at minus 18, 1. So we did count an occurrence there. Oh yeah, that makes sense. We were at 50, we did minus 68, which is, where is it? It is here. So we did cross the 0 once, that makes sense. Then we do plus to point at 82. Oh no, yeah, that's correct. Then, wait. Oh, of course, that's my mistake. There we go. Here, I'm not doing the modulo 100. So now, 82, okay, and we get 6 at the end, which is the result we are expecting. That doesn't mean it's necessarily correct, but it's more likely to be correct. So if we replace this back to a fold L prime and getting the second value and making this return an int, let's see what we get. We do get 6 for the test input. Before we move on, I just want to that's the zeros. If this is the additional 0, this is the zeros. And that is the diff, I suppose. Because I don't like leaving those X and Y thing. We do get 6 for the test input. Let's see if this is correct for... That's the right answer. Okay, so this approach worked. Perfect. Let's move on to day 2. So I briefly looked at this like 10 minutes before starting the stream, so we'll see how that goes. This is about finding range of ideas and just finding the ones with a weird, peculiar shape. This feels like a brute force. But there might be a better way to do this. do I have the guarantee that the ranges do not overlap? They don't seem to overlap in this example, but I don't know. This doesn't say anything about the number of, like, whether the ranges overlap or not, or no. So I probably can't make assumptions about the fact that they don't. My naive idea was to look at the size of the numbers in the range. Like, if this is like this is 3 and 4, so only ideas with 4 digits can be invalid for this puzzle. So we can probably just iterate over the invalid ideas of that size, which are very easy to generate, rather than iterating over all of the ideas of the given range. Yeah, I think we can try that. So let's do some setup. Download the input for 2025 Day 2. Let's look at what it looks like. Okay, looks pretty similar to what we would expect. Day 2. Let's copy the test input so that we can try our code on a known example. There we go. Okay. And I'm almost tempted here to just do some very basic parallelizing, because we're just going to be applying a function on each line. Each input, let's do the thing again where I'm using parsec, even though it's completely overkill. I am parsing every line, and our input is of course a list of tuple of int and int, and I am parsing every line by doing begin is passing a number, then we pass the character dash, and then we pass a number. Oh wait, no, it's not separated by line, so I can't do that. Okay, so this is gonna be parse with, and we are gonna parse with line separated by the symbol comma, where a line is, well, not line, range, where a range is a number, the symbol dash, and then another number. And we return that as a tuple begin end. Okay, so we have our input, which is a list of ranges. I'm tempted to have a look at control parallel strategies. There we go. And do a par map if it's a function that's in there. Par map, there we go. That basically does the map in parallel magically for me. And I will just use error par, it's perfectly fine. Okay. Which is a bit of premature optimizations. But I do like the fact that this, doing the parallelization is going to be basically, because this is going to be doing a sum of find invalid, basically. We of map find invalid. We apply this function on every range, and then we do the sum, where find invalid is going to be our function. If I replace this with this, par map r par, and suddenly, hey, this is parallel now. which is why I think it's worth it, even though it's technically um, like premature optimization. Now, how do we find the invalid ideas for a range that has a beginning and an end given to us as a tuple? I think we want to find. Is there a log base? Oh, is there a log 10? Because if I look at log 10 of like something like this, Google to the rescue. If there were a log 10 function, it would be not in base. Okay. There is a log in the prelude. And in numeric, let's have a look. And there is log base. Okay. So if I were to do a log base 10 of this, I'll get that. I then do a ceiling on this and I get 3. Perfect. And just to check, if I do 100, I get 2. Ah, that's a problem. So I'll need to do a +1 on this. If I do this, I'll still get 2, but if I do this, I get 3, which is what I want. And if I do 999, yeah, okay, that should be fine. Okay, so that gives me the number of digits, which is important. And I want then, let's write a function for this. I want the nearest even ID size. That given an ID gives me like an int. And that's going to be, again, a log base 10 of the value, on which we are going to do a ceiling to get... It's actually going to be +1 on the value, as we saw. Then a ceiling to get a round int number. And then we are going to divide that by 2 and multiply by 2, I think. Wait, or do I need to? So I get 3 with this. And I want rounded to the nearest. So if I do a divided by 2 there. So it's one of those cases where I do a +1 div 2 multiplied by 2. I do +1. Divide, and then I get 4. Yeah, okay. And I have like 4. Yes, that's perfect. So I do that. I get the ceiling. I do +1. I then... I'm going to write it the other way around, I think, by using this operator instead, which does the same thing but the other way around. We do +1, then we do log base 10, then we get the ceiling, then we do +1, then we do div 2, and then we do times 2. Let's try this to see if this works. I want to print the test input to see that this was passed correctly, which I don't doubt if this compiles. And then let's try nearest on 99, on 100, and on 566, and on 9999. If we compile this, and run day 2, pass error here. Yes, I need to make this undefined for now so that at least it compiles. Oh, yes, what am I doing here? I want to do a for of print not nearest thing on this list of numbers. Oops. There we go. What did they mess up? Wrong order of arguments. That's a traverse. No instance for floating int. Aha, so indeed I will need to convert that from an int to something that on which log can be done, which is going to be a floating. I never remember how this converts. From integral might be correct on this one. Let's see, if I try to search for int to floating, will it give me to ID unsafe coerce? No. From integral, that's the one I have in mind. Where are you from originally? It's in number, so it's not going to be correct. Okay, so let's have a look at floating, which is the one we need. Is there a function that converts into a floating value? Because I've been using ceiling, round, truncate, and so on to convert back. Too rational, perhaps? Let's see, if I try too rational of an int, or rather, can I use this as a function from int to floating? Oh, this is a constraint. It's for any floating, of course. That makes more sense. So to double. No, okay. From integral won't work, I suppose. It does. So from integral was the right one from the start. Okay. Perfect. So our input is passed as tuple 11, 22, 95, 115. That looks good. And for our nearest even ID size, we get that this is an ID size of 2, this is an ID size of 4, ID size of 4, ID size of 4. Perfect. I think that's good. The logic here being, since the IDs are invalid are twice the same string repeating, only even-sized ideas will be invalid, meaning I don't need to check odd size IDs at all. Okay. So, what do we do here? I guess I could start with this is going to be also a sum of I'm going to get a could write this as a do block in a list, I suppose, because I'm going to want to get a size. I'm going to want to iterate over all the sizes that are valid. For instance, if we do from 11 to 115, only IDs of size 2 can be invalid in that range. If we do 11 to 4099, then IDs of size 2 or IDs of size 4 can be invalid. Which means I will need to know, I will need to go from, for each ID, going from the nearest even ID size of the begin, which I'm going to actually name. So we're going to have size begin, which is going to be that. Size end, which is going to be that. Oops. And then we are going to iterate over a range, which is size begin plus 2, size end. So we're going to iterate over the even integers of size. Okay. Now for a given size, so we're looking at ideas that would be invalid of size 2. We need to generate, it's going to be basically all of the ideas of size divided by 2, basically. Basically, my reasoning here is this. If I'm looking at invalid ideas of size 4, then all of the ideas that don't start with a 0, I need to be careful, that don't start with a 0 of size 2, so from 10 to 99, all of those are like make invalid ideas of the form 10, 10, 11, 11, 12, 12, and so on, all the way to 9999. So the range, so the list of invalid ideas of that range is just basically all of the values of that size divided by 2. Now the only thing is I need to check that they actually fit within the range. Okay, how do we do that? I guess I can simply generate the values and iterate over the invalid values of that given size, which is a bit brute force here as well, but not in a way that I think is too bad. Yeah, I think it's not the worst. So we're gonna need something which is gonna be like our segment size, which is gonna be, of course, the size divided by 2, which is fine since we know it's even. And we are gonna want to iterate over all of the candidates, which are going to be, so if I have something of size 2, it is everything from 10 to 99. If it's something of size 3, it is everything from 100 to 999. How do we express this? So if I want to think the things of size 2, that would be size 3, that would be -1. That gives me the starter. Yeah, okay. So that means the candidates will be values that range from 10 to the power of segment size -1 to 10 to the power of segment size -1. I'm gonna put the parentheses here to make it very explicit what's happening. That's our candidate. That's all of the possible values that could be invalid. And now, well, that's our segment. Our candidate will be the segment plus the segment times 10 to the power of the segment size. And we keep it if actually we could just return a boolean here and here use count true, I suppose, which is a small helper function in my library of Advent of Code stuff. I think it's in the list. Count true is count number of things, like given a list of Boolean, give me the number of ones that are true. So this is going to be count true, and here we return candidate is greater or equal to the begin. Oh wait, is it the range inclusive or exclusive? Inclusive, because here 11, 22, 11 and 22 are both invalid. Okay, so it's gonna be the candidate is within the range, so greater or equal to begin and less or equal to end. I am making here the assumption that there's never gonna be an invalid range in which the end is less than the beginning. I hope that's true, because otherwise I'm wrong. So, to sum up, for a given range, we are looking from a beginning to an end, we are looking at the size of ideas that can be wrong. Then for each such size, so if we're going from 22 to 4,000 something, it's going to be ideas of size 2, ID of size 4. For each such size, we know the segment size is going to be that size divided by 2. We generate all of the possible valid segments that will yield an invalid ID. And we get an invalid ID, which is our candidate. And now the only question is that candidate greater than the beginning and less than the end of the thing? So we are only iterating over the invalid ideas rather than on all ideas. And since we're iterating over things divided by 2 in terms of log size, that should be a lot better than brute force, even though here it is still a tiny bit brute forcey. Okay, let's make this compile. And when it does, we are gonna want to find that for this test example, we are expecting this gigantic amount. Let's see. Indeed, we don't really use anything from parsec in here. Here indeed, I am not. What's happening here is I'm doing a log base and then a ceiling. So I'm converting an int to something that's floating and then back into an int. And the compiler is like, well, since you're chaining those two functions one after the other without telling me what's the type, I can't know for sure. By default, it picks double, which is what I want. But we could use here instead, I could make it explicit by saying what is ceiling. Ceiling will be from a double. And now with this annotation, the compiler knows, or should know. There we go. Now the compiler knows that this is the double function, and therefore there's no longer any ambiguity. Okay, I get something completely wrong. Wait. No, I get something so completely wrong that it makes absolutely no sense. Am I running the actual... Yes, I'm running day 2. Okay. So, well, this is very broken. Let's investigate. Just for sanity checking, I should get the exact result if I do a normal map here. I do. Okay. Oh. That was not correct. Although that wasn't correct, but not in a way that should result in... Yeah, that's even worse. This expression here reads basically like generate a list from the first value. If I have that x equal 3, this will be x plus 2 all the way to 10 will be 3, 5, 7, 9. So I'm doing size begin plus 2 all the way to size end. Okay. So let's say I have a segment size of 4. And I should therefore get this will be for 4. I will get the list of values from 1000 to 9999. So I get all 4 size ideas that give me an invalid 8 size ID. Then this is probably what's wrong. Because here I'm saying 4 is my segment size. So if I get 9847, for instance, I'm doing 9847 plus 9847 times 10 to the power of 4. Oh, that should be a 7 here. No, that seems to be working. That's correct. That gives us a ID that's the repeat of 2 different things. Okay, so let's move this function as a separate function so I can test it individually. This gives me, given a tuple int, an int gives me, I guess for now, a list of int. I'm going to do guard here and return the candidate. And here, this is going to be purely the list. Let's try this by, instead of doing this, doing a traverse with a print of find invalid. Is it going to be big? No. Wait! My code might be correct. We are not looking at counting the number of invalid ideas. We are trying to count their sum. So I can't read. That's the lesson here. So let me actually just try immediately to see if this works. Because then this becomes immediately, I can go back to this. And we're doing a sum there again. I'm going to keep my guard, so we're going to get only the candidates that are correct, and we return the candidates, and then we do the sum. I went too fast. If I had read properly. So for the test input, we get 12277775554. 12277775554. So we get the correct value for our test input. Let's see if what we generated for the real input is correct. That's the right answer. Okay, perfect. So it did work. This logic worked. I just didn't realize I needed to return the sum of the ideas rather than the number of the ideas. So yeah, this is not too bad in the sense that we're not iterating over the entire range, but only over the possible wrong values in the range by looking at the size of the ideas. It's still iterating over a bunch of values and then pruning the search space by like, oh, is this one actually within the range? But it's definitely less than iterating over all of the values. So I think it's okay. What is part 2? Oh no, okay. So now I cannot just say I need ideas of a given size. I need to, if I want to keep the same approach, I need to generalize to all prime divisors. I need to generalize to all prime divisors of a given ID size. plus 1. Okay. I think the logic that we're doing here of looking at the size of the range at the beginning and at the end and being like, okay, well, if we're starting with two numbers, then only things that could yield a valid ID, a invalid ID of size 2 makes sense. So I think we can keep most of the logic the same and avoid brute forcing for part 2. Yeah, it's basically what I want to do here for part 2, but, well, not all of them, but, you know. So let's try to do the same, because I think we also need, okay. So now, I'm gonna introduce another function, which is get ID size, which is the first part, which is the +1 from integral log base 10 ceiling double. That's this part. And this one is now get ID size. Okay. So here for part 2, we just get the ID size. So now we're gonna go through all the possible size, including size 3, because size 3 would be, there are invalid ideas of size 3. Now, segment size, rather than just being the size divided by 2, segment size is going to be any number from 1 to size -1. Well, to size, because I want the case where size is 1 to be counted as, well, that will never happen. So size -1 is correct. And now we need to guard that size modulo the segment size is 0. So an idea of that size can be made by combining ideas of that segment size. Okay. So now we have a given segment size. Well, I will need to know how many times I need to repeat. So I will need a div mod there. This is gonna be segments, and I'm gonna, well, how do I name the modulo here? Check, and no, reminder. And that's size div mod the segment size. We guard that the reminder is 0. And then now I have the number of segments, which is what I want. I iterate over all of my segments the same way. My candidate is going to be slightly different because now it's not just doing this once, it's doing it a given number of times. So this is going to be a how do I do this? Because this is a repeat segments of an operation, where repeat gives me a list. So it's going to give me a list of operations. Let's say functions that will do the right thing and shift by 1. And the way to then get my proper thing, my candidate, will be a fold R using dollar of my segment. And here is the function that I'm repeating, and the function I'm repeating is going to be given some value n, do n plus, well, no, do the segment plus n times 10 to the power of the segment size. Let me try this here in GHCI. So if I have a segment size that is, let's say 3, and the size that's 9, so I have a segment that's 3 because that's the division. What happens? Let's say I have a segment that's 1, 2, 3. What does this give me? Of course. I need to do this in one line. Fold R with the dollar function application of the segment as my first value of this thing. What do I get? Something that's completely wrong. Okay. Oh, of course, I'm wrong. This is repeat, in this case, segments of this. Unexpected. Interesting. So repeat. Oh, not repeat. That's the wrong one. That's the wrong one. I want the one that given an int and an a gives me a list of a, and that's replicate. There we go. So that gives me, aha. So this is the wrong, so this will be replicate segments minus 1. And that will give me 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so I just need to change this to being a replicate segments minus 1. Let's rewrite this like this. We got the candidate, we returned the candidate. Okay. If this compiles, that should be it. If it works, for part 2, we are expecting 417-437-9265. Not there yet. Four one seven four eight 22588. That's wrong. Okay. Okay. So let's move this function as being its own top-level function for now, so that we can test it on known quantities. For instance, what if I do, and here I might just do not the sum, but to find all of the invalid ideas. So if I do from I suppose I could try to just do a traverse of print find invalid of the test input, and we can compare what we get here with what we have documented here. Oh, yeah. you are gonna have to be... Okay. So we get 1122 for this one. We don't get 111 for this one. Okay. So immediately we have something that's wrong here that we can test. So print, I could try, since this compile, stack GHCI. I want to load this one. Perfect. Do I have find invalid in scope? I do have find invalid in scope. But find invalid isn't going to be helping me a lot. But I do have... So we know that for this second thing from 95 to 115, something is wrong. Oh, I suppose I could remove the segment -1 if I were to give 0 as the first value there. Yeah. So if I do 95 115, what's get ID size? Of 95, that's 2. 115 is 3. Perfect. So we're going to be iterating over those. Segment size. So the one I'm missing here is 111. So that's a segment size of 1. And the size... Ah, there we go. This find invalid is still doing a +2 here, so I would be skipping some of the ideas. If I do that... Now I'm finding 111, perfect. And we do end up with 4173, 417. Ah, wait, no, still wrong. Okay, so where do we get wrong? This one we get 1911, that's correct. 999, 1010, that's good. We get this one here, so that's okay. Oh, the same is counted more than once? Oh, oh yeah, I suppose this one can be made of segments of size 1, of size 2, and of size 3, but it is the same value. So I need to deduplicate them first. I could use nub here. But nub is horribly slow, and nub ord would be a lot better. But where is it? Data list extra. Do I have extra in my dependencies? I seem to have extra in my dependencies. Okay. Oh, I might even have it in my... I don't. So let's just add here, let's remove the duplicates. And now we only have to do something once. And now we get this number here. And how does it compare? 417, 437, 9265. Now it is correct for the test input. Let me just clean this. I'm going to make this a function again as part of this. Which is maybe a bit premature. We haven't confirmed it actually works yet. But oh well. 417, 437, 9265. So let's try this value here. And that's the right answer. So that was day 2. Now, I have not read day 3 yet at all. So give me 1 second. Let me have a quick look. Oh, is that the code that generates all of the ideas? You could do it. You could do it as a list comprehension, as a do block in the list for readability, I think. Because your first outer map is on the size, the R value. Then your second is on all of the values of that. I am not sure if that's correct. Or how do you handle... Using show is smart. But here, you're just doing show of x on one value at a time? And I'm not sure exactly how you would then create, like, concatenate several of... You do a concat, so there's that. Oh, I see. 1, 2, R. Yes, I see. There we go. Oops. 1 second, I need to go back to Twitch. There we go. Okay, so let me copy it in GHCI. I think I do it as a list comprehension, as a do block in the list. So this would be wrong num here. So for each, so R here would be the ID size, I suppose. So size from 2 onwards. Oh, it's not the size. I see. It is from the number of replicas. Well, okay, so you have a problem there, which is you're iterating over an infinite list of replicas, but also iterating over an infinite list of numbers to then replicate. Which means you'll never do more than 2 replicas of a given value, because you will never finish iterating over your list of numbers, because you're doing replicas from 2 onwards, and then you do like base, like segment from 1 onwards, and then you're doing, which is pretty smart, a concat of show of x in a list. Well, I suppose a replicate replicas of show of the segment. And that gives you indeed a bunch of wrong ideas. But since you will never finish iterating over the list of segments, you will never try replicas greater than 2. So if you could, like, if you could constrain this, then you could then have something this and like take it as long as you have things that are valid. But now the problem is you're doing a for loop on the first infinite thing and then a second for loop on the second infinite thing. This one is never going to finish either. But otherwise, yeah, that works and it's very smart. It's a thing I was trying to avoid here, is to use that you're doing here that I was trying to avoid, which was the using strings basically. Because here, this whole thing with the segment size and everything, I could have instead done exactly that, convert to string, concatenate. But I wanted to have a purely numerical solution, which is why I used the fold of applying this function here, starting, actually, I could rewrite this to be 0 and segments. I think that's a bit cleaner. 40028128307. 40028128307. Okay, that works. So we start with 0, and for each of the segments, we are applying this function, which is doing the segment plus the previous value times the 10 to the power of segment size. Okay, so, sorry, let me go back to reading part day 3. Okay. From 1 to 9, so no 0, okay. Each line is a bank. Need to turn exactly 2, maximize the thing. Okay. That doesn't seem too hard, in the sense of, like, if there is a 9 anywhere before the last digit, that's the one we want to turn on. Because by definition, it will be greater than any, turning on like any 80 value or 70 value or anything like this. So if there is a 9 in any of those values, any of the digits, we want to use that one. That's pretty basic. The question then becomes, how do we detect that there isn't a 9? How do we do this? There is an n-squared thing, which is the brute force solution, but I would like to avoid that, so let's think about it for a second. Well, I suppose for the first digit, I suppose I can probably do it in linear this way. Whenever I encounter a digit that's higher than the one I have selected as my first digit, I can replace it. I know it's greater. If I don't, if I find a digit that's not greater, then I can consider it for my second digit and then try to improve on that. Yeah, that should be. And since whenever I pick a new first digit, it replaces. Yeah, okay. I think that can be done linearly. Find the maximum and then the total output. So we are doing a sum of the maximum on each line. Perfect. So let's download the input for day 3, have a look at what it looks like. Okay. Pretty big. Which is why I think we probably want to try to avoid doing some n-squared if we can. I'm kind of tempted to just copy this. There's no point. So here, passing the input, I don't think I want to actually change. I think our input is going to be line of string. I think I'm just going to be using strings there. I guess I could use list of int, which is super overkill, but after all, why not? And then passing the input is doing a lines to segment that string into a list of other strings, the lines. Let me just change my setup here. And then on each line, so map for each line, and on each line we're going to do a map on each character and a digit to int, which comes from. Actually, I'm using a different convention here. Interesting. On a lot of my project, I use first third-party stuff, then my code, and here I'm doing the other way around. That's fine. Okay. So part one, I'm going to copy what I've done here, which is to get control parallel strategies, because since we're doing a sum of something that's a function applied on every line, I can just do exactly that. Except it's not going to be called find invalid, but find greatest joltage. I will need to copy the example data as well. There we go, this one. Oops. There we go. You should not... Yeah, there we go. So that's our example data. And we're going to do a find greatest voltage, and I'm immediately going to make it a second function so I can test it in isolation. Find greatest voltage takes a list of ints, returns an int, and find greatest voltage will be, do I use a fold or do I make the recursion manually? I think I'm going to make the recursion manually because I will want to keep track of the fact that there's only one digit left, which a normal fold would not do. So let's go. And with what are going to be my accumulators for this, I'm going to keep track of my current best first digit, current best second digit, basically, which for now are going to be 0 and 0. And then go with first, second. How do I name those? Yeah, those are just the first and the second. Candidates, I suppose. If I am on an empty list something went wrong. Well, no, let's just, in this case, return first candidates times 10 plus second candidate. In the case where there's only one value left, I cannot consider it for my first value, I can only consider it for my second value. So it means I have to go recursively. I have to do this separately because I want to handle the case where an empty list is given, although it will never happen, but still. So I go recursively on the empty list, which is, it's going to be the same thing. This is going to be first of the candidates times 10 plus max of the second and the candidates and x. And if we have literally anything else, so we have some x value at the beginning of a list, which is the remainder of the list of the line called xs here, then if this x is greater than the first of the two candidates, I'm going to write it as a multi-way if, I think. Or I could just like write it this way, I suppose. Then in this case, we are going recursively on the rest of the lists. I am writing the fold manually just because I want to handle this particular case especially. We are going recursively with now a new thing, which is x as my first digit, 0 as my second digit, because this one is strictly greater, therefore it's better. And otherwise, if this x is greater than the second of my candidates, but not greater than the first, it means I continue with and this X value instead on the rest of the list. Otherwise, we go recursively with the candidates unchanged on the rest of the list. I could rewrite, I think I will keep this rather than doing something like X in the candidates, because that would be shorter, but I think this is less readable for a beginner. This is more readable for a beginner. And I want to try to keep my Advent of Code streams beginner friendly, even if my compiler streams are not. Okay, let's try this. Let's try printing. Let's do a traverse of print of find greatest joltage on the test input to compare side by side with what we have. Lexical error in string character literal. What the hell does that mean? Oh, is it because this is not the right syntax for new lines? Is it something like this? I never remember. It is, okay. Okay, so I am running the wrong day. That explains. So here I get, if I look at this, 98 for the first line, 89 for the second line, 78 for the third line, and 92 for the fourth line, giving me 357. That looks good. So we can copy this and try it, and hopefully it will be correct. That's the right answer. Perfect. Now let me read part 2. Aha. 12 digits in each bank's voltage is output instead of 2. I think the same logic applies. I think there is still a way to do it in linear time. And I think the logic is just that instead I'm going to have to rewrite it. I'm going to have to rewrite this. And instead of keeping like a list of candidates, I'll be keeping a list of the different digits so far, basically. And this is going to be it's still gonna be linear in the sense of like I'm gonna be doing a fixed number of things per number in the list, but this is gonna be basically for each number I encounter, is it greater than the most significant digit? If no, is it greater than the second most significant digit? And so on. And then I think the same logic of I replace whichever digit is the most significant, and then I replace everything afterwards by zeros, basically, if and only if the remainder of the list is small enough that I can do that. So let's rewrite this function to be working. So this one is the old one. I'm keeping it around just for reference. I will remove it afterwards. Find greatest voltage will be taking as an argument, which is the size, which is the amount of digits that we are looking for. So our accumulator is going to be a replicate size of 0. So now, when we are done with our recursion, we find the empty list at the end. What do we do? I could cheat and use a show here, but I don't want to do that. So this is going to be a fold R1, where given some digits x and y, we are going to be doing x times no. This is a fold L1. We're given some x and y. We're doing x times 10 plus y, starting at 0 on the candidates. Let's try this in GHCI just to make sure I am not completely wrong. This should be, I can't type. This should be, if I do this, but I have 1, 2, 3, 4. Could not deduce foldable. Is it because... Oh, yes, because folder L1 doesn't take a first argument. There we go. 1, 2, 3, 4. That works. So that's the result at the end. We have our list of digits that we have selected. We do this fold to create an integer. Now here is where it gets complicated. We have this x and we have the list of the things. What we need to do now is determine, is it better than one of the most significant digits? And so this is basically, I want to iterate over my list of digits. I want starting by the most significant, and if there is one that's most significant, I want to use that one. Since I'm not doing a regular for loop kind of thing, since this is Haskell, how do I do that? And I suspect, because there could be more than one digit that matches, but I could do, I think what I'm going to do, since I want to get the first digit that matches, I'm going to generate a list of possible values, a lazy list, and I'm only going to get the first element of that list, and that will give me okay, I'm going to do that. So this is going to be, I'm going to get a warning because of this. I know that this head is going to succeed, but it's not going to like this. How do I do this otherwise? Otherwise, I do this, the second recursion manually rather than doing the list thing. Let's do that. So, okay, we found an x value, an x digit, and the rest of the digits. I need to see which branch I take. This is the second layer of recursion. Select of my candidates of x and xs. And I'm going to be iterating over I want to go from most significant digit to least significant digit, which is the most significant is 0. But I don't want to be doing indexing on lists. That's horrible. I don't want to be doing indexing on lists. That's horrible. I can do this by doing the list so far, and I'm basically doing a zipper. There we go. That's an approach. And select will be taking all of the digits that are more significant that we are not considering in this case. So most significant, least significant, and then our x and the xs thing. And here we do a case of the least significant. If there is no longer anything there, that means x wasn't greater than any of the digits in our list. We don't need to keep it, which means we can go recursively again on with a list of candidates which is just our most significant. And on the rest of the list XS, we have ignored that X that we don't want to consider. Otherwise, if we have some digit D and a bunch of digits DS in the rest of the least significant stuff, there are two possibilities. If D is greater, if X is strictly greater than D, then one thing happens. We replace the value. Otherwise, if it's not, which is the easiest case, so I'm going to write it first, if that one is not good enough, then we continue trying to select. Our most significant digit has been... could I do a reverse here? It's going to make a difference, I think. I'm just going to do it this way. So here we consider the digit D. The new digit in the list X is not greater, so we add it to our list of most significant. We continue the recursion on the rest of the list of the digits. X and XS haven't changed. They will not. Now is the case... Well, I guess I could reverse them. But here is the interesting case where, okay, this digit is better than the one we had before, therefore we need to keep it. That means we can go to the next digit in the list, and our new list is going to be our most significant digits plus a list made of X and a bunch of zeros where the rest of the list significant digits used to be. And that go will go on XS here as well. Okay. So in theory, since I have kept the old version, I can compare, because find greatest voltage 2 should be the same thing as the old version that was doing the 2 manually. And so this one will be old for now, just so that this compiles. Something is wrong. Okay. Something is wrong. Let me type the functions here. This is a function that given a list of int, which is my candidates, which is going to be this replicate size 0 at first, and a given int, given a list of int, will ultimately give me an int. And select given a list of int, a second list of int. An int will give me ultimately the int because it does the recursive call to go. So where is something wrong here? Yes, this is select. Here. So here I'm doing a select with a empty list of my candidates. Oh, yes. Wrong type signature here. Aha. So something is wrong here. So most significant is a list of int. That's fine. So here ds is a list of int as well. So something is wrong with my syntax here. This on 1, 2, 3 should be... Okay, so that's fine. Oh, this is probably a matter of operator precedence. So if I do Because if I do 0 before that, I have a problem. But if I do 0 before that, I don't have one. So that's just a matter of this needs to be between parentheses. Okay. So if this is correct, I should still be getting 98. Aha. 90, 80, 92. I see. I see what the problem is. Here, I don't test that there are enough digits left in the list that it's fine to replace this one. How do I know that it's fine to replace this one? The length of this thing must be greater or equal than the length of this thing. So let me let's switch them back, then else x greater, and the length. Calling length like this is a bit ugly because it's going to be a bunch of linear time, but since the core of this is we're iterating over the digits only once, which means we're not doing a brute force, I think it's fine. The length of remaining digits in the line must be greater or equal than the length of the digits remaining post this one. And now if I do that, just gonna... now I get 98, 89, 78, 92. So we are still getting the same value for part 1. So part 1, where we had 357, if I replace this find greatest joltage old by find greatest joltage 2, I should still get 357. I do, which means I can remove the old function and only keep this one. I can remove this for now, and for part 2, this just becomes same thing, but size 12, if I remember correctly. 12. So between the fact that we parallelize on each line and we are only considering each digit only once, this is very fast. We get for the test input 3121910 something 3121910778619 3121910778619. That looks good. So let's test this value. And there we go. And that concludes day 1, 2, 3 of the Advent of Code in Haskell. Now, it is not too late yet, which means I have 2 options. Option 1 is I redo those in another language. Option 2 is I go back to my regular compiler project that I don't want to abandon completely throughout the month of December. Is any of those problems approachable in Brainfuck? Because the biggest problem in Brainfuck is parsing the input. Let me have a look at your code. Ah, nice. Yes, I figured that nationalize was not the proper spelling. I figured what you meant. Let me go back again and have a quick look to see if any of those days are easy to parse. This one is not the worst. But doing it in Brainfuck would require probably doing it the ugly way. No, that's gonna be an arbitrary... No, that's gonna be monstrous in Brainfuck. Day 1, perhaps? Day 1, part 1 is probably not too monstrous in Brainfuck. If I cheat a tiny bit. Yeah, I think I can try part 1. So, what do I mean by cheating? I have a small compiler. Compiler is too strong of a word, but it is technically a compiler that I'm using that converts brainfuck with functions into raw brainfuck, and it makes writing code in brainfuck a lot easier. So if I look at 2024, for instance, what do I have in brainfuck? If I look at day 2, perhaps, like this function main has still some raw brainfuck in it, but it's still a lot of just like calling actual function names, even if they are defined in terms of, raw brainfuck instructions. This gets converted into proper brainfuck, and then we can try it. Okay, so let's try day 1, part 1 in brainfuck for fun. 2025, I have the make file, and that's about it. Okay. I have run. Okay. So I will need and since it's been a year, I don't remember the syntax of my own language on top of brainfuck. So let's open one from last year. And let's try to do it with as much raw brainfuck as possible, because I think that's more interesting. I'm gonna keep this, however. I think that's useful. Read number. That pushes. What is that boolean that it pushes on the stack? I don't think I need to push a boolean on the stack on this one. I'm gonna remove this. Actually, I'm just gonna copy the main as well. What we're gonna need to keep the list, the number of zeros. So we're gonna need to keep. The way I write brainfuck is to use it like a stack. So I keep where my pointer is the top of my stack, basically. So I think what I want to do is to push a number, and those functions are actually doing 4-byte numbers, so like 32-bit int in the background. I want to have A0, which is going to be the number of zeros we have encountered. And we are going to want to have a 0, nope, not 0, a 50, which is where we are at the moment. And then we are going to want to iterate over the actual characters of the input, basically. The only problem is what's my outer loop like? Because my outer loop needs to be something of like the same shape as this, where I try to read something and either it succeeds or it doesn't. I suppose I could change. If I'm only doing part 1, then the only thing I care about is the end thing of each rotation, which means I could consider doing the modulo 100 of, and modulo 100 is only the last 2 digits of the number. And I could consider that minus is going left is doing plus 100 minus the number. That's the same thing. Okay. How do I do this then? I think I have no choice. The root of the thing will be I move one character to the right in my tape, and I read one character from the input. And while that character is not zero, that means I have things to read and to process, and therefore I go into a loop where I'll go with process like step, let's say. And at the end of that thing, I'll have processed the given instruction and I will have consumed the new line. So I will be on the next line and I can try. Assuming this leaves me back on the top of the stack before the thing, I will need to move one again, read a character. When that gives me 0, then I have reached the end of my outer loop and I can just pop the current position that I don't care about, print the number here, which will be the number of zeros we have encountered, and print an end line, and I will be done. Okay, so that's our main. I'm gonna rewrite just this as being a loop like this. So now we have on top of the stack the first character of a line, which will be either L or R. Here I will probably want to just do something completely different in each case. I think I might need to duplicate it first. I have macros for this. Wait. What? Oh, wait, it's... Yeah, there we go. Oh, it's in the lib, probably. Here we go. Prelude. There we go. Those are my functions I have access to. So I'll probably want to duplicate the character. Okay. But I do have an equal function, I think. There we go. Okay, so I can do that. I can do that. So if the first thing on top of the stack is equal to L, do something, assuming that this will leave me on a value on the stack in the same position, I can then do if it's R, do something else, and I will need to be in the same position on the stack. Brainfuck, actual Brainfuck doesn't have functions, so this will, like everything I put here will be completely inlined. And here at the end, I'll need to do some kind... I need this to always leave me on the top of the stack, so I will need to do a pop of the character regardless of where. So I need to guarantee that I'm those things in it do the same, leave me in the same state of the stack. Okay. So this is going to be a step L, and there's going to be a step R. Which are going to be completely duplicated, and that's fine. This one is actually probably pure. Which is going to give me, given a stack that has 2 int and a character on top, will give me at the end a stack with 2 integers on top. Because yes, this very basic compiler that generates the brainfuck has some amount of type checking in it for convenience. So the step R, which is going to be the easiest one, which is going to be completely impure, but that's fine, will be taking int the character. No, I'm going to pop the character there. I know which one I'm in, and I'll just push a random character there. I can just push 1. Okay. And this will be returning the stack in this shape. And in fact, it doesn't take... Yeah. Okay, so I'm in the case where the first thing was an R. So now I need to read the last 2 digits, or actually just reading a number, I suppose. I can probably use this. And I probably don't need that. What was this about? While is digit. Yeah. Here, I think this was for something specific in day 2 of last year. Here, I can just pop the character, I think. Okay. Oh, wait. That's wrong. This needs to be 32-bit integers. And this is probably gonna be pure, actually. Okay. So now we know we are in the case where we're moving to the right. I can read the number. And now my stack has, so my stack had the number of zeros, the current position, and after the read number, it has the number by which we're moving right. So now I can just do an add integer to add those 2 ints together. I need to do a modulo 100. Do I still have modulo on integers? I do have modulo on integers. And it's the modulo is the second on the stack. So I need to push 100, swap, do the modulo, and that is my new position. Then if it is 0, I need to go push. I'm gonna check something. in day one, my values... Okay, I need something that's greater than 1 byte, so I need an integer. Okay, that's annoying. So what I need to do here is I have 2 integers on my stack. I need to check whether the first one on top is different from... is 0, and if it is, I need to add +1 to the second one. But it's brainfuck, so every operation is destructive, so I'm gonna have to do... I duplicate the int. What do I have in my prelude functions? Do I have... I do have equality on ints. Fantastic. Which means I should be able to write this as... So if it is equal to 0 and I'm back on the same shape of the stack of the 2 integers, I can swap them. I can push 1, I can add them, and I can swap them back. And that's it. Which means now I can do the L version. And the L version will be exactly the same thing, except this is not going to be an add like this. This is going to be a swap first. And a subtraction of the position. Oh, do I have... Oh, this is going to be bad. This is going to be bad. In the sense of like, if this causes an underflow, I'm going to have a gigantic 32-bit int, and my modulo is implemented by doing subtractions. So I think I will want to do the subtraction of the value of how many times we've moved left, and I will want to do plus 100 to guarantee that the modulo operates on something that's positive. And that way, do I have the guarantee it's going to be positive necessarily? I don't. I don't have that guarantee. But I can do a while less than... what do I have? While it's less than 0, that'd be ugly. Because less than 0, how is that gonna work? Is it even gonna work? I think I'm not even gonna attempt. I'm just gonna let it do some absolutely horrible modulo. It's gonna be very slow because it's easier. Okay, so that should be... if I try to make the brainfuck file... Yes, that's a good point. I am not in the right folder for this. I'm tired. Okay, unexpected E, unexpected parenthesis on line 26, colon 6. Is it because that's not the proper syntax? That might just not be the proper syntax for this made-up language of mine. Yep, it requires parentheses. Okay. That's not the only problem. Okay. Oh, wait. Line 50. It's those. Okay. This is the shape of our generated brainfuck file, but 90% of this file is actually the print a 32-bit integer, which comes from here. It's done here. It's this nonsense with a ton of inline brainfuck, as you can see. That one function is monstrous. Okay, so let's test this. We have for day one this example. I'm going to put it in a test file. Oops. If I go here and I look at what I do for my make file, this will just be... So if I want to make... Okay, now I have the compiled version of our program. If I run this with the test input, I get 767, and that I think is completely wrong. This was I've been meaning to try to learn Lean, and Lean, the recommended install method is as a Visual Studio Code plugin, which I find weird, but that's the official recommended thing. But as you can see, I have done nothing beyond what is here a hello world. But yeah, it's something I've been willing to learn, and I think the Advent of Code is gonna be a good way to learn that. I get 767, which I think is completely wrong because we are expecting to find 3. So something went very wrong. So let's debug this. And by debugging, let's print the stack at the end of every step. We will see immediately, since the type checker has been happy with this, it's likely that that we're not blowing up the stack completely. Instead, so I will need to make the brainfuck version that will keep the debug annotation. It might have stripped it. Yeah. So I will have to remake it myself using my small little thing. Given... Yeah, I would be surprised if there wasn't a way to do some Lean in Emacs. That feels like there's some overlap in interest there. So I want to do this, and I will get this file in input. Yeah, I mean, I have no opinion on VS Code because I simply never use it. So I feel like to have an opinion, I would need to use it. Okay, so this is the generated version, the non-optimized generated version. I'm open it here so you can see it actually. Where I haven't tried to so since any character that's not a brainfuck character is ignored, I can still keep all of the functions. But since there's no functions in brainfuck, it's just all inline. So you can see that main inline step, which has step L, which is just all inline and so on. But those should be keeping... Does this keep? It does keep the debugging symbol. Perfect. So it is there at the end of the step. And here is then print. Again, the print integer is the worst part of the thing. Okay, so now I have a brainfuck file that has the special debug symbol that most interpreters recognize, which means I can run my debug thing. What does it take as an argument? Okay. I suppose it just takes this, and I'm gonna give it a test input. Okay, so the shape of the stack looks good, which suggests that... we're not... Oh, so maybe the modulo is not correct. Okay, because after one iteration, we have found 0 zeros. Wait, why do I have a 2 here? And this prints 767. Because I need to pop the character first. Since I was not popping the character first, the end of the loop was on this thing in the stack. Use the comma instruction to read one character from the input, finds 0, we are at the end of the input, exit this loop, and I would pop the int, expecting to pop this one, but I was actually popping an int something here, so I would pop those 4 bytes, and then read those as 4 bytes. With this change, now we're printing 2, which is wrong, but less wrong. So we end up on something negative after the first step. I don't think that's... Yeah, that's correct. Minus 68. So that should be... What am I trying to do here? I'm trying to look at what this means as a signed 32-bit integer. If I try to do this as a... minus 18, okay. And that's the problem. We should have done... I think the problem is this. I think the problem is the modulo, where this thing will be registered as being... The modulo didn't work, I think. I think is the problem. Because here we are at minus 18, which is 82, basically. So we find... Which 0 do we find? We find the one here, after the 48. Then 1, 2... Huh. After this one, we end up increasing by 1. After... Oh, this is 37 instead of 0. Okay. That's 55. Okay, so indeed we have a 0, then 1, 2, then a second 0, this one. Then 99 here, in theory. Well, 1 below 0, yeah. Aha, and then the L99 should bring us back to 0, but since the modulo is broken, that doesn't work. Since the modulo is broken, how do we fix it? Because the problem is basically this is treating all of the numbers as unsigned, basically. Because there's no notion of like signed and unsigned. This is just me putting meaning on the things. So I would need Oh, that's something I can do, I think. Hmm. I could always do a push 10,000 or something like this before doing the what's the biggest number that we are putting in the let me put this where you can see it. Is there more than 3 digits ever? Nah, there isn't. Which means a plus 1000 minus the thing should always be positive. Meaning, I think the simplest way to do this is before I do this, after I do this thing, I just push 1,000 on top of the stack, and then I add the numbers, and then I do the modulo. I get 3 now, because now my int on top of the stack, which represents the position, is never um, negative. It's always above 0. It's a bit ugly to do it with the plus 1000, but you know, it works. Which means if I were to do a run of day 1, I get 1191, which was the correct answer. That's day 1, part 1 in pseudo brainfuck. The actual brainfuck looks like this. Oh yeah, I didn't recompile it with the... So it has still all the stuff in line. But as you can see, it's basically, rather than having to copy and paste all of this stuff manually, I just put print integer and it just copies this snippet I've written once for me and it's done. And the rest is just basically inlining the basic things. Like main is this push a bunch of numbers, step is this thing. It just inlines the stuff for me. And yeah, the difficult part remains basically using this language means I don't have to worry about writing stuff that's unreadable, but the logic of like I have to manually manage my memory byte by byte remains. Okay, I think I'm gonna stop here for this evening. The question is, do I switch to the compiler to make some progress on it? I could. I worked on Sunday on something that's not urgent. Maybe I could continue on it. I'll have to figure out how to like cut the thing and upload half of it on YouTube, but I have to figure that out. I could, I suppose, quit the stream and relaunch the stream. That way I have 2 different recordings and it makes my life easier. Nah, I'll figure it out. Okay, let's move on to the compiler.